Good morning, students. So in last class we discussed about some history of electric charge and what are the different methods of charging a body, in which we discussed mainly three methods of charging a body, that is charging by friction, charging by induction method and charging by conduction method. So let us take a review of the previous class. So in previous class we discussed about the charge. So charge, electric charge is an fundamental property of any body which produces both electric and magnetic field. And the electric charge was first named by, or though we can say there are generally two type of charges exist in the nature. One is positive and another one is negative. And this positive and negative nature was first named by Benjamin Franklin. So as per Benjamin Franklin, we can say when glass rod is rubbed with silk, when glass rod is rubbed with silk, the type of charge acquired by the glass rod is positive. Because in case of the friction of glass rod with silk, there is a transfer of electron from the glass rod takes place towards the silk. That is why the type of charge acquired by the glass rod is positive. In second case, we can take when amber is rubbed with woolen cloth. When amber is rubbed with woolen cloth, then the type of charge acquired by the amber is negative. Because amber receives some extra charge particle from the woolen cloth. And this type of charge particle that acquired by the amber is called negative. So this was first studied by or first named by Benjamin Franklin. And also we discuss about the method of charging, that is induction, conduction and friction. Now if we look towards a atom and its structure, from atom and its structure we find atom is the smallest particle which can be a part of which can be or which can take part in a chemical reaction. And if you observe the atom and atomic size and the nucleus, various things we find in the atoms that already we discussed in your atomic chapter. So in atoms we mainly find there are three particles that exist inside an atom. One is proton, second one is electron and third one is neutron. And proton is being positive charge, electron is being negative charge and neutron is being neutral. Understand? And when we observe the size of the atom, the size of atom is the order of 10 to the power minus 10 meter, and the size of nucleus is the order of 10 to the power minus 15 meter. So this can be also known the radius of the atom, and this one is also can be taken as the radius of the nucleus. So size of the atom is the order of 10 to the power minus 10 meter, and size of the nucleus is the order of 10 to the power minus 15 meter. Okay. So in this class we discuss another important thing, that is about the properties of electric charge. Okay. And when we observe the properties of electric charge, generally we find there are various properties or electric or characteristics a electric charge possesses. Okay. Out of which we can say the characteristics like the nature of charge. Okay. And second thing, that is the conservation nature, discrete nature. Okay. So we discuss one after another. Okay. So when we take different characteristics of an electric charge, we find the first characteristics or properties, that means you may take properties of electric charge. Properties of electric charge, or we can say that is the characteristics of electric charge. Okay. So properties of electric charge, or we can say characteristics okay. So first characteristics of electric charge is that electric charge is a scalar quantity. Charge is a scalar quantity. Okay. Electric charge is a scalar quantity. Okay. And the magnitude of an electric charge equals to 1.6 into 10 to the power minus 19 coulomb. Okay. Comes to the second property, that is discrete nature of electric charge. Or simply we can say that is quantization of charge. Okay. So discrete nature of electric charge or quantization of electric charge said that inside an body or inside an atom, the total charge is not arranged in a continuous manner. Okay. They are generally discontinuous inside the atom. Okay. And when we measure the total charge inside the atom, we find the total charge is an integral multiple of either charge of one electron or proton. Okay. So quantization of a charge or discrete nature of charge says that the electric charge which inside an atom or inside any body is not continuous. Okay. It is generally discontinuous in nature. Okay. And when we measure the total charge of the body, the total charge of the body is an integral multiple of either charge of one electron or proton. Okay. So that's why we can say quantization of electric charge says that total charge of any body is an integral multiple of charge of electron or proton. Okay. So that's why the total charge of any body is written by, if I consider the total charge of any body as Q. Okay. So the total charge of any body will be plus or minus NE. Okay. Where N being integer. Okay. N is an integer. Okay. and when we consider the charge of an electron, that will give minus Ne, and when we consider the charge of proton, then it will gives plus Ne. So, quantization of electric charge says the total charge of any body or total charge of an atom is always an integral multiple. N is an integer, integral multiple of a charge of either one electron or charge of one proton. Okay. So, when we consider electron, that will be negative, and when we consider proton, that will be positive, and this concept is similar to the atomic physics concept, that is Q equals to Z E. Okay, where Z is the atomic number. Okay, this formula is similar to atomic physics formula Q equal to ZE or Q equal to NE. Okay, so always remember that N is always a integer and N never be a fraction value. Okay, N cannot takes place a fraction value, it is always a integer. Okay, so from this value we can calculate the number of electrons or number of protons that constitute the total charge of any atom. For example, a problem is always given in the exam like a total charge, suppose depending upon the quantization of charge, a problem always comes like given find total number of electron or proton. Okay, total number of electron or proton for a body having charge having charge 1 coulomb. Okay, okay, so for a body having charge 1 coulomb. Okay, so here, so if you observe the total charge given in the body will be 1 coulomb. So total charge Q equal to 1 coulomb, and here you have to calculate the total number of protons or number of electrons. Okay, so suppose we consider charge of 1 proton equals to E. Okay, and as per the quantization rule, the total charge Q equals to Ne. Okay, so here N is the number of protons or number of electrons. So N equals to Q upon E. Okay, and charge of proton, that will be 1.6 into 10 to the power minus 19 coulomb. Okay, so that's why if you substitute here, so N equals to 1 divided by 1.6 into 10 to the minus 19 coulomb. Okay, so coulomb that will cancel because N is an integer. So N will be 0.625 into 10 to the power 19 number of electrons or protons, or N equal to 6.25 into 10 to the power 18 number of electron or proton constitute charge of 1 coulomb. Okay, so the total number of electrons or protons, they like to 6.25 into 10 to the power 18 number of electrons or protons will constitute a charge of 1 coulomb. Okay, so that is called discrete nature or quantization of electric charge. Okay, second रे देखिबा कोन quantization rule परे आमे secondly measure करूचे कहार ना conservation of electric charge. Okay, that means conservation of electric charge बुझेला first property quantization of electric charge. Second property is कौन आसुची ना second property says that the total charge is, third property, that is conservation of charge. Okay, conservation of charge says that in an isolated system, okay, in an isolated system, the algebraic sum of positive and negative charge is always constant. Okay, that means we can say in an conservation of electric charges in an isolated system, the total electric charge remains constant. Okay, in an isolated system, total electric charge remains constant, or we can say another things, that is charge neither be created nor be destroyed. Neither be created nor be destroyed. It can only transfer from one body to another. Okay, so conservation of electric charge says the total charge of a system is always constant. Okay, jekonosi system if we observe, then the total charge of that system remains same. Okay, and when we write a chemical reaction, we say the charge before the reaction is equal to charge after the reaction. Already we have discussed in the nuclei chapter, that is law of conservation of charge always satisfied by a nuclear reaction. Okay, in that case also we find the total electric charge is constant before the reaction and after the reaction. That is also a conservation of electric charge property. So that's why we can say the total charge of any system is always constant. That means charge neither be created nor be destroyed, it only transfer from one body to another body. Okay, so in order to discuss this, we can take a simple example that will give more clarification about the electric charge conservation. Okay, so when we consider an electric charge conservation by considering a uranium nucleus, okay, fission of an uranium nucleus. In case of fission of an uranium nucleus, we find when U90 to 238, okay, U90 to 238 breaks, okay, as it is unstable nuclei, when it breaks it gives thorium 90 234 plus a helium nucleus of He24. Okay, so when we break a uranium nucleus, okay, it convert to thorium and helium. Okay, so in such nuclear reaction, we say it is satisfy law of conservation of charge. Law of conservation of charge means we can say before reaction, before fission, the total charge Q equals to here 92 E. Okay, and after fission, the total charge Q dash, suppose I take total charge Q dash equal to 90 E plus, in case of helium the charge will be 2 E. So resultant will be 92 E. So as per the reaction process, here we find Q equal to Q dash, means the total charge before the reaction is equal to total charge after the reaction. That means total charge is constant. Okay, so that is called conservation of charge. Okay, so conservation of charge says in an isolated system, total charge of a body remains constant, or charge neither be created nor be destroyed. It only transfer from one body to another body by three methods, that is friction, conduction and induction method. Okay, now another property is about the additive nature of charge. Okay, fourth property we can say, fourth characteristics of electric charge is that additive nature of electric charge. Okay, Additive nature of electric charge says if we consider any system which consists of a number of charge particle plus and minus, then what will be the total charge of that system. Okay. If I consider this duster consists of a number of positive and negative charge particles, okay, then what is the total charge of the duster. Okay. So, when we measure the total charge of any system, suppose I consider here this is a system which contains a number of charge particles like plus q1 minus q2 plus q3 minus q4 plus q5 minus q6, okay, minus q7 minus q8 and plus q9. Okay. So, these are the different charges that consists or present in a system S, okay, and all the charges possess different magnitude value. Okay. So, in order to calculate the total charge of that system, we have just add all the charges, okay, and after calculation the resultant charge left in the body will give the total charge of that system. Okay. So, that is why we can say in such case the total charge Q will be Q1 minus Q2 plus Q3 minus Q4 plus Q5 minus Q6 minus Q7 minus Q8 plus Q9. Okay. So, that will give the resultant charge, suppose that will be Q. Okay. So, that will give the resultant. So, additive nature of charge says that the total charge on an extended body is equal to the algebraic sum of all the charges present in that system. The total charge of an extended body or in a total charge of any system is equal to the algebraic sum of all the charges located at the different point of that body. Okay, different point of that body. So, that is why additive nature in general form we can write as per the additive nature of charge, the total charge of any system will be the algebraic sum of all the charges present at the different point of that system. So, that is why plus or minus q1 plus or minus q2 plus or minus q3 plus or minus q4 like this. Okay. So, this will give the total charge of any system as per the additive rule. Okay. Fourth property or fifth property देखिबा. Fifth property is about the nature of force of the charge. Okay. Fifth property of electric charge is about nature of forces. Okay. Nature of forces. Okay. And nature of forces we can observe by the frictional electricity. Suppose I consider two different glass balls. Okay. One glass ball is A and another glass ball is B. Okay. Suppose both the glass balls are rubbed with silk. Okay. And after rubbing we make attachment with attached by two glass plates with the help of the fine threads. Okay. When we take friction of the glass ball with the silk, then we can say both the glass balls acquires positive charge. Okay. And when they hang from a common point, suppose the common point is O, then we find A and B both moves away from each other. Okay. Both A and B moves away like, so initial position both the body, okay, and when both the body left, then we find both the body moves away from each other. Okay. And moves away from each other means we can say both A ball and B ball acquires the same type of electric charges. Okay. Same type of electric charges means A acquires positive charge and B acquires the positive charge, and when positive and positives are suspended from a common point, they experience a repulsive force. Okay. So, that is why A ball and B ball moves away from each other. Okay. Second case also we can take, if I take two different balls, like one is ball A, that is glass, okay, and another, that is, suppose we consider as amber ball, okay, another ball B, that is amber. Glass is rubbed with silk and amber is rubbed with woolen cloth, okay. The type of charge acquired in the glass ball is positive, okay, and the type of electric charge that acquire in the amber is negative, okay. And when positive and negative bodies are placed close to each other, then we find they experience a attraction force. That's why positive and negative body comes closer to each other, okay. So positive and negative bodies comes closer to each other means we can say they acquires opposite nature of charge, and because of that opposite nature of charge they attracts each other, okay. So in conclusion we can say, when we take similar type of charges, also you may take here one is amber, another one amber ball, and this one is also another amber ball, then we find both the amber ball moves away from each other, okay. So that's why we can say there is a repulsive force exists when we place two similar type of charges close to each other, and when we place two dissimilar type of charges close to each other, they experience attractive force. So nature of force between two electric charge says that like charges, okay, like charges, like, or we can say that is similar, okay, like charges repel each other, okay. Secondly, unlike charges, that's why I say dissimilar, dissimilar charges attract each other, okay. So nature of force between two electric charges, two like charges repel each other, and two unlike charges attracts each other. That means the force between positive and positive is repulsive, force between negative and negative is repulsive. So here we can say force, if we consider force positive, two different charge Q1, another one is Q2, then the force will be repulsive, okay. If I consider plus minus, then force will be attractive. If I consider minus and minus, then force will be repulsive, okay. And if I consider minus and plus, then force will be attractive, okay. So that's why unlike charges attract each other and like charges repel each other. Understand? Next property of electric charge is about the transfer of charges, okay. In a property we say electric charge can transfer from one body to another body, okay. This one is very important. Okay, transfer of charges, okay. That means we can say a charge can be transferred from one body to another body, okay. But when they are contacted by a conductor, okay, transfer is possible from one body to another body when they are connected by a conductor, okay. As we see in conduction method, and when two different bodies are connected to each other, then charge flow from one body to another body, okay. And flow of charge always depends upon the degree of electrification, okay. Degree of electrification means the amount of charge present in a body, okay. Again I repeat, charge is capable of transfer from one body to other if they are connected with each other with the help of a conductor. Okay. The transfer of charge always takes place by transferring free electrons. Okay, and the transfer of electric charge depends upon the degree of electrification. Degree of electrification means we can say when we consider transfer of electron from one body to another body, then we can say electron always transfer. Okay, suppose I consider transfer of electron. Okay, the transfer of electron always takes place from lower degree of electrification, lower degree of electrification means low charge density to a higher degree of electrification. Okay, that means electron always transfer from lower potential region to higher potential region, okay, or low charge density to high charge density. But when we consider transfer of positive charge particle or transfer of protons, okay, protons always transfer from higher degree of electrification to lower degree of electrification. Okay, higher degree of electrification, that means higher density to lower density. Okay, electrons always transfer from low potential to high potential, but protons always transfer from higher potential to lower potential. That is the mode of transfer when they are connected by a conductor. Okay. Another thing, so we can say during the transfer of charge particle, the total charge of the system always constant. Okay, it always satisfy the conservation of charge. Okay, so during the transfer of the charges, the total algebraic sum of all charges should be constant. Okay, another thing, so we can say transfer of charges shall be stopped. Okay, another point you may come to your mind. I say transfer of charge takes place from lower potential to higher potential or higher potential to lower potential depending upon the type of charge or nature of charge. Okay, but you may question here, up to what limit the charge transfer is continue. Okay, that means up to what region, okay, or up to what value the transfer of charge takes place. Okay, the transfer of charge always takes place up to a limit that both the body gets equal amount of charge. Okay, and when the body acquires same degree of electrification or same value of charge, then the electric charges transfer stops. Okay, so we can say the transfer of electric charges stops when both the body gets same degree of electrification or same value of the charge. Okay, another property we can say, the transfer of charge takes place from one body to another body, but it is not possible to transfer all the charges of a body to another body. Okay, it is not possible to transfer total charge of one body to another body. Only we can transfer the charge up to a same degrees of electrification. Okay, that means if I connect here, if I consider a body is charged by 10 coulomb and another body is charged by suppose 0. Okay, and when we connect the body with body A with body B, then transfer of charge from 10 coulomb moves towards the 0 charge. Okay, and transfer of charge is possible when body A is 5 coulomb and body B is 5 coulomb, and when the body gets equal charges, the transfer of charge stops. Okay, so it is not possible to transfer all the positive charge of a body to another body. Okay, Another important property that depends upon the transfer of electric charge is that you may ask the question here, will a body reduce its mass or increases its mass when there is a transfer of charge? Okay, जदि गोटे बॉडी रू आम चार्ज ट्रांसफर करुचे गोटे अन्य बॉडी को बा गोटे बॉडी जदि चार्ज रिसीव करुची वेदर देयर इज ए चेंज इन मास ऑफ द बॉडी. Okay, suppose I transfer electron, okay, and suppose I transfer positive charge both, okay, will there is a change of mass of the body? Okay, so body रे mass change habo ki nahi? Okay, when we transfer electron from one body to another body, generally we say electron is a material particle. Electron is a material particle. Okay, electron is a matter, and when transfer of electron takes place from one body to another body, so definitely there will be a change of mass. Okay, so we can say transfer of a charge from one body to another body results their change in mass of the body. Okay, whether you may transfer the electron or whether you may transfer the proton. Okay, when proton and electron both transfer from one body to another body, they always affect their masses. Okay, though electron is a light mass particle, but since electron is a material particle, so that's why when transfer of electron takes place from one body to another body, there is also a change in masses of the body. Suppose I consider an example like an increase of a positive charge or decrease of negative charge. Okay, जदि आम गोटे बॉडी रे पॉजिटिव चार्ज इंक्रीज करूचे बा गोटे बॉडी रो नेगेटिव चार्ज को डिक्रीज करूचे, then there will be also increase or decrease of the masses of the body and vice versa. Okay, so we can say when there is a transfer of charge from one body to another body, then there is a change of mass between the bodies. Okay, another concept depending upon the charge is that we say generally the charge of an body is always takes an integral value, that is q equal to plus or minus ne. N is an integer. Okay, but recent discoveries of the nucleus or recent studies of the nucleus find a hypothetical type charge, and that charge is named as a quark. Okay, quark, that is a particle that found inside the nucleus. As per the recent discoveries, quark is a charged particle which can takes the magnitude of a charge as 1/3 or 2/3. Okay, quark is a particle that is a hypothetical particle that exists inside the nucleus. It is that means scientists also discussing about that this is a hypothetical particle which exists inside the nucleus, and the magnitude of that quark particle will be either 1/3 or 2/3. So depending upon the different nature of charges, we divide quark as like. So quark is an hypothetical particle that exists inside the nucleus and whose charge is around 1/3 or 2/3. So I make a table in order to identify the different types of quarks. Okay, suppose name of quark, okay, symbol used for that quark, and charge. Okay, okay, suppose depending upon the different type of charges, we mainly categorize 6 charges, 6 quarks. Okay, like if we consider up, okay, up quark, Okay, that means we can say a proton and the electrons and the neutrons are also can be discussed depending upon the quark particles. Okay, so there are 6 type of quarks, that is up quark, down quark, top quark, bottom quark, charm quark and strange quark. Okay, suppose I consider up quark. Okay, there is a up quark, the symbol of that up quark is U. Okay, and charge of up quark is 2 by 3 times charge of electron or proton. Okay, so up quark is generally positive, so that is 2 by 3 charge of one proton. Okay, second, that is down quark. Okay, so down quark is symbolized by small d. Okay, and charge of one down quark will be minus 1 by 3 e. Okay, third, that is charm quark. Charm quark is symbolized by symbol small c and its charge value will be 2 by 3 e. Okay, another one is, that is strange quark. Okay, strange quark is symbolized by small s and its charge will be minus 1 by 3 e. Okay, number 5, that is called top quark. Okay, top quark is symbolized as small t and charge of a top quark will be 2 by 3 into charge of one proton. Okay, number 6, that is bottom quark. Okay, bottom quark, that is small b and charge of bottom quark will be minus 1 by 3 e. Okay, so detailed study on quark model or quark theory will be given in your higher classes. Okay, if we discuss the type of quarks, generally there are 6 type of quarks. There will be up quark, down quark, charm quark, strange quark, top quark and bottom quark. So quarks are the hypothetical particles that exist inside the nucleus. Okay, and always we can convert or we can find protons, electrons and protons, neutrons and electrons in terms of quarks. Suppose if I convert proton depending upon the quark theory, okay, proton is being charged positive. Okay, proton has a charge plus 1 and as per quark model, one proton is consists of 3 quarks. Okay, one proton will constitute of 2 up quark and another one bottom quark. Okay, so there are 2 up quarks. So if we consider protons, so it consider a up quark, okay, another up quark, okay, and one down quark. Okay, so 2 up quark and one down quark will constitute one proton. Okay, so if we measure the charge here, charge of that 3 quarks, up quark has the charge 2 by 3 e plus another up quark, that is 2 by 3 e. Okay, and there is one down quark, so that is 1 by 3 e. Okay, and if we calculate all the values, then what we find, the resultant charge will be plus 1. Okay, plus 1 e. Okay, so that will be one proton can be represented as 3 quarks, that is proton can be written as quark with UUD. Okay, so U means that is up quark and one down quark. Okay, so resultant charge will be positive. Okay, how can we represent neutron as a quark? Okay, if I write neutron as a quark, neutron, its charge is 0. Okay, charge of neutron is being a neutral particle, and in quark model we write neutron as it consists of one up quark, okay, and there are 2 down quarks. There are 2 down quarks present inside the neutron. So a neutron can be represented in quark as UDD. Okay, one up quark and there is 2 down quarks. Okay. So, if we measure the charge of that neutron depending upon the quark theory, a up quark consists of 2 by 3 e, 2 down quarks the minus 1 by 3 e, minus 1 by 3 e. So, resultant charge will be 0. Okay. So, a neutron can be represented in quark as UDD, 1 up quark and there is 2 down quarks. Okay. So, quarks are the hypothetical particles that found inside the nucleus. Okay. And there are generally 6 type of quarks, that is up quark, down quark, charm quark, strange quark, top quark and bottom quark. Okay. And the charge of that all the quarks will be like this. Okay. We can say that quarks are the hypothetical particle that contains the charge of magnitude 1 by 3 or 2 by 3. Okay. These are the hypothetical particles given by the scientists which are present inside the nucleus. Okay. Understand? So, in next class we discuss about the Coulomb's law in electrostatics, okay, and the different vector forms used to measure the Coulomb's law. There is another question also arises in your exam, like if there will be find the nature of force between two electric charges, if it is given like this. Okay. Suppose one things, find the nature of force. Find the nature of force. Okay. First is given Q1 and Q2 greater than 0. Okay. Q1, Q2, there is a comma in between Q1 and Q2. If Q1 comma Q2 greater than 0 means we can say here Q1 greater than 0 and Q2 also greater than